Okay, so I'm going to let you take over the webinar, Marcos, in 3, 2, 1.
Asia and the Pacific is the region of the world that typically experiences the greatest number of internal displacements linked to disasters globally on an annual basis. In addition, there are statistics pointing to the possibility of tens of millions of people, potentially up to 90 million people, who may have to move in the future as a result of the impacts of climate change. Now, we have broad statistics such as those that I just cited, but what we don't necessarily understand to a sufficiently detailed degree is how many people are likely to have to move in the future and where are they living now. The reason that data like this is important is because it can help us underpinning activities, operations and activities and policies that can serve to prevent people from having to move in the sense of helping to mitigate the hazards and the other challenges that they face, and also in terms of enhancing preparedness over the short term in case of disaster to reduce shocks. So what we're really trying to do through the Risk Index for Climate Displacement, or RICD, is to enhance data systems and tools that will help us have a more complete picture of some of the risks that we might face in the future.
Disasters in the past decade have caused 225 million internal displacements in Asia and the Pacific, accounting for 78% of the global total.
My name is Michelle Chijic. I attended the opening of the launch of the project today, RICD. And this, for me, I would say was quite eye-opening. It was an opportunity to meet with people outside of my comfort zone, outside of the natural kind of interlocutors that I have on a day-to-day basis. And that included people from academia, from think tanks.
We're aiming here to dramatically increase the reliability and the granularity of data on the likelihood or the risks of people having to move in the future as a result of the impacts of climate change. In order to do this, we've enlisted the support of 21 expert institutions from universities to co-create or co-develop with us an advanced analytical model that will help us in understanding these risks in the future.
We have gathered many experts here to discuss the framework and methodology on how we can really understand the link between migration and climate change.
I think oftentimes we work in siloed situations, but really this is such a complex problem that we cannot be addressing it by ourselves.
Because my background is in data analytics and big data and artificial intelligence. So in this symposium, the domain expertise, they know the problem. They don't know how to solve it. Where's the data? How to build a model? How to estimate or evaluate the result? That's my experience can contribute.
We have a lot of experience in the region working for the community-based approach and helping government to develop the policies.
Coming here is important because I can learn from my colleagues, so I can take it back and customize it to suit the local context.
For us, this is not just talk. For us, this is an indication of our willingness and commitment to act. The Philippines was just elected a host of the LNDF board. And for us, we think that it's a step in the right direction.
The world is looking at us. The most vulnerable communities are looking at us. Not only the migrant and displaced community, everyone affected by climate change is looking at all of us to come together, academia, private sector, UN agencies, communities, member states, and operationalize what we talk about.
So I think today's event basically showcases and highlights the importance of thinking outside of the box, of thinking what we can do differently, how we can team up together and address and mitigate against climate change.
Good afternoon, and welcome to the third session of the Climate Mobility Innovation Lab Brown Bag session. My name is Marcus Rosales, and I will be your host for today. The Climate Mobility Innovation Lab Brown Bag session series is brought to you by the UN International Organization for Migration, co-organized with the UP Resilience Institute. Our speaker for today is none other than one of UPRI's very own Executive Director, Dr. Mahar Lagmay. Dr. Lagmay is an academician of the National Academy of Science and Technology and professor at the National Institute of Geological Sciences at the University of the Philippines. Apart from being the Executive Director of the UP Resilience Institute, he is also director of its core component, the UP Nationwide Operational Assessment of Hazards, or NOAA, Center. He received his bachelor's and master's degrees from the University of the Philippines and holds a PhD degree in Earth Sciences from the University of Cambridge. He was a visiting scientist at the Geophysics Department of Stanford University from April 2006 to March 2007. Upon receiving his PhD, he returned to the Philippines and has been involved in numerous research efforts related to natural hazards. He lectures on Philippine disasters by virtue of having hands-on experience in search and rescue and forensic analysis of major Philippine catastrophes. He is a recipient of the Presidential Citation for Search and Rescue Work in Ginsaugon and the 2008 Outstanding Research Award from the DOST. On June 20, 2013, he was presented with the Professional Regulation Commission, or PRC, Outstanding Professional of the Year Award in the field of geology for his accomplishments. In the same year, he received the 2013 Outstanding Filipino Award, an honor given by the Junior Chamber International Senate Philippines to Filipino men and women whose exemplary achievements are worthy of emulation. Dr. Lagmay is also the first Asian to have been awarded with the Plinius Medal by the European Geosciences Union, or EGU, for outstanding achievements in interdisciplinary natural hazard research and natural disaster engagement in the Philippines. Dr. Lagmay is a leading international scientific expert on natural hazards, and he has published more than 50 peer-reviewed journal articles, mostly in international ISI journals. Without further ado, I am handing off the spotlight to Dr. Lagmay for his presentation.
Yeah, thank you very much, Marcus, for the introduction. Now I'll just share my screen. I believe that I only have 20 minutes to present all of my slides, but it will be about the manifestations of climate change hazard impacts in Greater Metro Manila and vicinities. Okay, I think I have the wrong slide. Just a minute. I'll unshare. Just a minute. I lost the slide. Ano?
Hey, sir, would you like us to share your slides for you?
No, it's okay. I got it already. I got it now. Yeah. Okay, April, I'll continue. The Philippines has been at the top of the World Risk Index for the third consecutive year. And this is understandable because aside from the vulnerability of the people in the Philippines, we are in the Pacific Ring of Fire, where we have a lot of earthquakes and a lot of volcanoes that explode from time to time. Apart from that, we are also in the typhoon belt, where we receive maybe about 20 typhoons that enter into the Philippine area of responsibility each year. We are practically in the typhoon belt of the world. Now, all of these hydrometeorological events have corresponding hazards like floods, rain-triggered landslides, storm surges, strong winds, and in the reverse, sometimes in the extreme, without any precipitation, we have droughts. And climate change due to anthropogenic activities will make these hazards bigger and, according to climate scientists, more frequent. This is quite well known. There have been publications that say that extreme events like 100-year flood events will happen more frequently. Instead of having it once every 100 years, they will happen every 1 to 30 years according to new floods, or at least the probability of it happening becomes bigger. This is largely based on the publication that was made by Marzulli in 2009, wherein they studied climate change phenomena exacerbating hurricane floods along the U.S. Atlantic and Gulf Coast, and they reviewed the spatial patterns of the floods. In terms of the increase in the frequency of large events, according to IPCC, projected percentage changes in frequency are larger for rare events, which has a high confidence, according to the assessment report. In the Philippines, what's happening is that in Metro Manila, we had several large flood events. In 2009, we had this devastating Ondoy event. 2012, Habagat. We had the 2013 Habagat, 2014 Habagat, 2015, 2018 Habagat, and then 2020 Ulysses typhoon, and then the 2024, which is just last year, the Karina event. Here are just some pictures of the devastation where many people got killed, the frenzy, and that's the image of Ondoy in 2009. Last year, we had Karina, and those are the images that came out in social media. Each time the large flood event in Metro Manila happens, this is the site or the photo that we see. There are floods in Marikina, which is always flooded when we ever have large flood events in Metro Manila. And along that river, which is called as Marikina River, we have a station in Santo Niño where we have been collecting records of the increase in river water level. So those river water levels have been going on or measurements have been going on since 2002. We have it until last year, and you can see that Undoy in 2020, in 2009 had about more than 22 meters. It's actually 23 meters. We had the 2009-12 Habagat event, which had floods over 20 meters or rise in water level, and the most recent, Karina. Ondoy was a 180-year rain return event, and Karina was once every 100-year rain return. In terms of the water levels, and if we can use that as a proxy for the year rain return of floods, we can see that we had several large flood events more than once every 100 years returning. We had the Ondoy, the Ulysses, and then the Karina. So instead of having the probability to be about once every 100 years, we have it increasing to once every maybe 10 to 12 years. So big floods in Metro Manila have become more frequent. Another evidence for, or another manifestation of climate change impacts as projected by climate scientists is rising sea level compounded by ground subsidence. According to the IPCC AR6 report, relative sea level rise contributes to increase in the frequency and severity of coastal flooding in low-lying areas and to coastal erosion along most sandy coasts with high confidence. Sea level rise, according to previous works in the Philippines, is about 5 to 7 millimeters per year. However, these records are actually compounded by groundwater extraction, which makes coastal areas sink as well. Now, if we look at the Copernicus datasets, we can see the Philippine waters having high or large amounts of sea level rise compared to other areas. And if you look at the scenarios from 2014 to 2023, the red parts of the oceans indicating sea level rise is much more than other areas. If we look at the global linear relative sea level rise of Manila, it is about, I just looked at this last week, it's about 14.2 millimeters per year. So it's worse than the previously recorded measurement or estimate from previous studies. As I said, it is compounded by groundwater extraction that leads to ground subsidence. In these images from INSAR satellite images and processing, you can see the blue parts indicating the areas where land subside. These are areas, at least for the north part of Metro Manila, to be subsiding near the coast. And the coastal subsidence is very large. It's not in millimeters, but it's actually in centimeters. So the largest that we can see from this graph happens in Giginto, Bulacan, that's B, wherein we experience about 10.9 centimeters per year of ground subsidence. So the effects of the combined sinking of the ground along coastal areas as well as sea level rise has impacts on the coastal ecosystem. Rising seas implicates an increasing ocean temperature, which would itself reduce the rate which corals can grow. And as sea level increases, the area at which light penetrates to decrease reduces the amount the seagrass can photosynthesize. And sea level rise can impact the mangroves mostly. This is due to their location in the intertidal zones. Landward migration is also a problem, which we actually see happening already. So there are coastal towns that are now submerged by seawater, and people have to go using boats to attend mass, as shown in these pictures. Now, coastal inundation, we tried to simulate it using the combination of sea level rise and groundwater sinking in the coastal areas of Metro Manila. And by 2010, this is the simulation of the inundation due to high tide. By around 2060, this would be the scenario. And then by 2100, this would That would be the scenario. 2110. That's a correction. Another evidence or manifestation is persistent flooding in coastal areas. According to the IPCC, in coastal cities, the combination of more frequent extreme sea level events and extreme rainfall, river flow events will make flooding more probable, which is, according to the assessment report, has a high confidence. In Central Luzon, in particular, the Pampanga River Delta, which is part of the Pampanga River Basin, which is a very, very big basin, 9,759 square kilometers area, we find flooding to occur quite frequently. And you see that the river, which is Pampanga River, when there's a big typhoon or monsoon rains, where there's heavy precipitation, the river overflows. And when it overflows, it covers a large area. That's an approximately 100-meter wide river becoming a 10-kilometer wide flood, which you can see in this satellite image. The blue line, the curving line, is the Pampanga River, the one to the left. And when there's flooding, as seen from the satellite image, it becomes roughly about 10 kilometers wide. There are many villages that get flooded in Pampanga and Bulacan, as you can see from this image, overlaying the barangays or villages as against the floods. And we found that all of these big flood events have been becoming more frequent. 1972, we had that big flood. In 2011, we had big floods in the area. In 2015, we had big floods in the area as well. 2020, we had big floods. In 2024, we had big floods as well. So these coastal area in the central Philippines region are suffering from the combined effects of ground subsidence, sea level rise, and increased precipitation on a yearly basis. Another manifestation is the numerous landslides occurring in large numbers during single events. According to IPCC, climate change exacerbates the rate and magnitude of several ongoing land degradation processes and introduces new degradation patterns. I'm referring to landslides that occurred in the caldera rim of Taal volcano, which actually erupted in the year 2020, to be exact, on January 12, 2020. There are about 5,669 landslides as of the time when this slide was prepared. I believe that they've counted more, roughly around 10,000 already, and they were all found mostly in the northern part and the western part of the Taal volcano's caldera rim. These are some examples of the drone images of those degradational events, the landslides. And they actually correspond to areas where we had a lot of deposits of tephra when Taal volcano erupted in the year 2020. The rainfall amount was about 437 millimeters accumulated over 24 hours. And we can see that based on the records of a synoptic station there, a 421.6 millimeter of rain corresponds to a 100-year rain return if delivered over the span of 1 day. And if you have climate change happening as projected, that's the orange curve that you're seeing, that 100-year rain return, that equivalent amount would instead be more frequent, happening, or with the probability of happening once every 46 years. These are the effects of that intense amount of rainfall that was delivered last year. It generated a lot of lahars, a debris field full of boulders, and a lot of tree trunks and branches. And the landslides that happened triggered lahars. So this is one of the areas along the coastal parts of Taal Caldera. We had landslides, and because of the intense rains, the landslides had a longer run out because it became wet and traveled as a debris flow. Since it was volcanic in nature, we identify them as lahars. Now, that event killed about 20 people, 18 to 20 people. It depends on the source that you're looking at. Buried them during that event, and they all say that it's the first time that they experienced such a flood. A lot of houses were covered. This boy survived. You can see the devastation of his house, but that boy was not able to spend Christmas anymore because his friends died from the lahars. These are some more examples of the lahar deposits. You can see the big boulders sprawled on top, a lot of tree trunks that came from the watershed, from the upper watershed, a lot of structures, a lot of material was buried. Large parts of the areas of Agoncillo, Talisay, and Laurel municipalities were covered in mud. Another manifestation would be the rise in total rainfall. Climate change is likely causing an increasing in average monthly rainfall in some areas due to warmer temperatures, leading to more evaporation and increased water vapor in the atmosphere, which can result in heavier precipitation events. This one comes from the paper of Jerry Bagtasa of UPIESM. From 1900 to 2020, you can see an increase in the total annual rainfall of Metro Manila. That would mean that even with small rainfall events, we have flooding that is experienced by many people in Metro Manila. We have increased dengue cases, like what was noted just this year. Metro Manila, Calabarzon, top dengue hotspots because it's linked with water, with flooding, leptospirosis as well. Cases have been on the rise weeks after Typhoon Karina last year. Another manifestation would be the consistent trend of rising temperatures. Global surface temperatures has increased faster since 1970 than in any other 50-year period over at least the last 2,000 years. That's of high confidence according to IPCC AR6. You can see here the temperature anomaly as determined from data of Pag-asa and processed by the Oscar M. Lopez group. And you can see an increase in the national annual average mean temperature from 1951 to 2022. Again, from Jerry Bagtasa of IESM, you can see the temperature rise over the period from 1900 to 2020, temperature rise happening in Metro Manila. And of course, this has consequences. There are no classes because of the extreme heat, because of concerns of heat stroke. And DOH, the Department of Health, has actually verified 6 deaths due to the rising temperatures. Now, another manifestation is the urban heat island. Increase in warm nights. The urban heat islands, where cities are significantly warmer than surrounding areas, are exacerbated by climate change, according to IPCC. In 2008, our group studied the urban heat island effect, and you can see that Metro Manila is more than 1 degree higher than the rural communities adjacent to Greater Metro Manila. A more recent study shows that there's urban heat island happening, or that phenomenon is happening in Metro Manila. Now, drought. Human-induced climate change has contributed to increase in agricultural and ecological droughts in some regions due to increased land evapotranspiration. Medium confidence according to IPCC AR6. And we are experiencing droughts with pests eating up all of the remaining crops. That's happening in Pampanga and also in areas of Bulacan. And according to reports, we have lost due to El Nino last year about 51 million pesos worth of agricultural crops. We also have this dam called La Mesa Dam, which supplies, from the last I read, it's about 90% of the supply of water of the entire Metro Manila. And during droughts or during El Nino periods, the water level goes down and is of serious concern. We had records of the water level going down drastically as compared to other years. That happened on September 28, from September 2018 to March 2019. Another dam which feeds La Mesa Dam, this dam is called Angat Dam, also had the same manifestation, wherein there's a drastic decrease in water level, which happened in 2018 and 2019. And if we look at the years for ENSO, we had a weak El Nino, and 2018-2019 corresponds to that weak El Nino, which probably was the reason for the drastic lowering of the water levels of these two dams. However, we are quite skeptical as well, because when we looked at the storms, during that year, 2018 to 2019, there were storms that dumped a lot of rain in the watershed of Angat and La Mesa. Now, maybe it was political. During that time, they were trying to push for the acceptance of the creation of a new dam along Sierra Madre, which is also located east of Metro Manila, probably to gain more acceptance. But this one needs more study. Another manifestation would be the strongest typhoons in the world. The proportion of intense tropical cyclones, category 4 and 5, and peak wind speeds of the most intense tropical cyclones are projected to increase at the global scale with increasing global warming with high confidence, according to IPCC AR6 report. And when we looked at the most powerful typhoons at landfall, this is an ongoing study that we're conducting with Joshua Agar of the College of Engineering. We looked at the historical records of cyclones, hurricanes, and typhoons. This just means the same. We have one word for it in the Philippines. We call it bagyo. Whether it's in North Atlantic or the East Pacific or West Pacific, they're called bagyo. But they have different terms depending on which ocean they are spawned. Now, when we looked at the historical record, Haiyan, Meranti, and Goni are at the top of the list in terms of wind speed at landfall. And then there are some from the North Atlantic, Labor Day, Dorian, Gilbert, and the rest. So Joanne, Monica, one from the Australian region, Winston, and then Zeb. 8 of the top 10 strongest typhoons at landfall in recorded history occurred after the year 2000. And the top 3 in the list made landfall in the Philippines, which I believe is a portent of things to come. In summary, here are the manifestations of the hazard impacts. There's an increase in the frequency of large flood events. There's persistent flooding in coastal regions, specifically in the north of Metro Manila. Numerous landslides occurring in large numbers during single events that happened in the Taal coastal areas. Rise in average annual rainfall, rising temperatures, drought, the urban heat island, which causes an increase in warm nights in Metro Manila, and the strongest cyclones in the world are all in the Philippines, with one having been experienced, that's Goni, which was experienced also in Metro Manila. That ends my presentation. Thank you very much for listening. Back to you, April.
It's actually Marcus, me, who's hosting this.
Marcus.
Thank you, sir. Thank you so much, Dr. Lagmay, for the very interesting and informative presentation. I'm definitely sure that our audience has learned a lot about the impacts of climate change and extreme weather in the Philippines. But I'm more certain that you have piqued the interest of quite a few of our attendees here. So the next portion is actually our question and answer portion. But before we move on to that, we would just like to set a few house rules. So first, please use the Zoom reaction button to raise your hand and wait for the host, me, to call your name and unmute you before you speak and give Dr. Lagmay your question. Second, for those who would prefer it, we will also be entertaining questions sent to the chat box. For those of us who are shy, don't have the best microphone right now, you can type that in and we'll get to you your question. And third, for those watching through our watch party in Fiji, we actually have a live watch party in Fiji now. So for those who are participating through that event, you may also raise your questions through our moderator on site, and then we will be calling your group later on so you can field your questions to Dr. Lagpay. Lastly, due to the limited time, we may not have enough time to entertain all the questions. But do not worry, unanswered questions will be forwarded to Dr. Lagmay after this session. So please just type that into our chat box, and we'll be giving that to Dr. Lagbay. And hopefully he'll be able to get back to us with answers. So at this point in time, we will be opening the floor for any questions any of our attendees here may have for Dr. Lagbay. On the get-go, we actually have one question for you, sir, from our chat box from an anonymous participant. So they ask, how do the rates of sea level rise and land subsidence in Metro Manila compare to similar challenges experienced by cities like Jakarta or Bangkok and other urban centers across the Asia-Pacific region?
Yeah, I know that the problem of ground subsidence is not unique to Metro Manila. It happens as well in other metropolitan cities of the Philippines. And I'm aware that ground subsidence is also severe in Thailand and Bangkok, and also in Indonesia. What I'm saying is that elsewhere, ground subsidence happens. In the same manner, sea level rise also happens in the Philippines as well as in other coastal areas because sea level rise is global. But the rates of sea level rise, as I presented, is I think higher based on the data, higher compared to other areas, a certain percentage more compared to other areas. And if I remember correctly, what I presented, it was around 14.1 14.1 millimeters per year. And elsewhere, it's less than 10, maybe about 5 or 4. So in terms of the sea level rise, the Philippines, I believe, is much more than in other areas or most of the areas. And ground subsidence, which compounds the problem of coastal inundation by seawater, it would depend on the metropolitan city. What I can say, though, is that in Metro Manila, particularly in Caloocan, Malabon, Navotas, or what we call as the Kamanava area, when we reported ground subsidence as early as 2004, when that got noted, got published, and was written in news articles, government did something. It used to be about 5 to 6 centimeters ground subsidence in that area, in Navotas in particular, and Malabon. But now when we looked at it, it was less than it's subsiding less than 1 centimeter per year. So that means that science can make us aware, and the people or government can do something about it when we know the problem. So that can probably be addressed also in other countries, also in hotspot areas for subsidence farther north of Metro Manila, like in Bulacan. And I guess the best solution is to provide surface water rather than not making it available for the population, and they resort to excessive groundwater extraction as their supply for their daily needs as well as their industrial needs.
It actually seems that the cases in the Philippines are a very, very good example for our regional neighbors and other coastal countries around the world who may be experiencing similar hazard impacts. We actually have another anonymous question for you, Dr. Lagmay. They ask, how has climate change intensified monsoon variability and extreme precipitation events across Asia Pacific, particularly in low-lying coastal megacities?
Yeah, that's an interesting question. As a scientist, I would like to just answer for at least Metro Manila, because Jerry Bagtasa of IESM has published something about it. And if I can just read it, you're referring to the cyclones. If I can just read it, just a minute. All right. It's a
Go
very
ahead, Dr. Lagbay. We're not
interesting
rushing.
quote. I actually tried to make a screenshot. He says that the total annual precipitation is increasing at a rate of 77.99 millimeters per decade. That's happening in Metro Manila. Decreasing simple daily intensity index implies that higher observed precipitation is due to the increase in wet days count rather than the intensity. Extreme precipitation is induced either by a tropical cyclone's immediate rain bands or remote precipitation effects by enhancing the prevailing summer monsoon flow. So that means that whenever there's a typhoon, we have the habagat rains enhanced. So we've experienced that. I showed in the presentation that we've had enhanced monsoon rains due to typhoons, the Habagat 2012, 2014, Habagat 2018, and Habagat 2024. He further says that tropical cyclone induced rain modulates annual rainfall variability and is estimated to contribute 45.2% to Metropolitan Manila mean total rainfall. So that means that there's an interaction between the typhoons and the monsoon rains, and it contributed a lot to the increase in total rainfall. And we see this modulating the amount of rainfall that we're seeing now.
I see, Doc. We have another question for you from this one is from Marvin Tejada. So Marvin asks, due to climate change impacts, how do affected communities how are they compensated for rehabilitation and recovery as a form of climate justice?
That's a good question. Well, we have the loss and damages fund. I hope the people get it. We have all sorts of mechanisms. We have the Green Climate Fund to be able to work on things better so that we can do better adaptation. But again, there are climate financing that should be available to people so that they can be compensated. We transfer the risk. Maybe we can get the insurance and so on. But I'm not really a climate finance guy. But you know, this is a problem that really needs to be addressed. That's the best answer that I can give.
Yeah, thank you so much, Dr. Lagmay, for that. Let's go to another question. We have another question. This one coming from Mr. Vincent Jans. So Mr. Vincent Jans asks, if massive urbanization leading to dense skylines across the world caused the heat island phenomenon, what is the most probable doable solution to reverse it back to, I guess, back to where it was before this temperature rise?
If massive what? Massive?
If massive urbanization
Okay.
leading to dense skylines caused the heat island phenomenon.
Well, The urban heat island is because of the release of heat that is absorbed during the day. The urban heat island that I was talking about is a measurement at night. So what happens is that it absorbs the heat, the sun, the heat coming from the sun, and then releases it at night. And it's largely because of concrete that has replaced a lot of greenery. So maybe to reverse it, we can be more innovative, try to make everything more green. The buildings can be green buildings. You can plant trees on top so that the cement will not be able to absorb and release the heat the way it does to contribute to urban heat island. Urbanization is probably something that we cannot stem because of the growing populations and the desire of people to have better things in life, more luxurious things and more infrastructure, more and more. With growth of populations, urbanization increases, and therefore we have to have more uh, uh, ways or green ways of doing things. That's the best, I believe. And also maybe because populations are growing and we know that in a dense population, it's hard to manage. It's hard to manage disaster risk reduction activities, and it's hard to do the management of such. Maybe try to decongest urban populations and spread it out so that there'll be more uh, uh, parks that have more greenery. There'll be more flood detention basins with more trees. Those are the best ways to probably stop urban heat island if we cannot stop the growth of populations.
Actually, I agree, Dr. Lagmay. These are actually things that we have to be mindful of, especially when we develop our cities, our towns, our communities. Um,
Planning is
we
very
need to be
important.
mindful.
Yes,
Definitely, we
planning
need
of
to be mindful
communities,
of these things when
very
we plan.
important.
Yes. I'll be asking a question now on behalf of our friends from Fiji. So they ask, in Fiji and the Pacific, our impacts are usually in outer islands and rural communities. We envision that in a few years' time, the effects will reach urban centers. However, there is not much investment in urban DRR. Please, if you can give some advice on how our interventions can be future proof, and what are some resources and tools that we can access?
Yeah, that's a very general question and quite hard to answer in one go. But I know that Fiji also experiences very strong typhoons. In fact, I believe that there was one there in the list that I presented that made impact in Fiji. I forget the name of the typhoon, but it was quite a strong typhoon. It's in the top 10 list. Now, here in the Philippines, disasters happen where, at least for hydrometeorological hazards, happen where the heavy rainfall is dumped, where the watershed absorbs all of those precipitated rain and makes it run off through the river channels and make the river channels swell. That creates the floods. If the communities are not prepared for such hydrometeorological events, then disasters happen. Now, disasters in the Philippines have been transferring from one place to another, depending on where the typhoon strikes. So, for example, we had Ondoy, which struck Metro Manila. We had Sendong in 2011, which happened in Mindanao, in Iligan and Cagayan de Oro, south of the Philippines. And then we had several in Central Luzon. We had several happening in the Central Philippines region, in Samar, in Leyte. So the disasters keep on moving around. It can also happen as far south as Davao, and it can happen as far north as Ilocos. Practically, even the mountains, even the mountainous areas, the capital city of the Philippines, which is Baguio, experiences floods. Even Banawe Rice Terraces, I saw flooding happen there. Now, the observation that the disasters transfer from one place to another is attributed mainly to where the hazard makes its impact, and also depending on how prepared the people in the community are. So with climate change, the large flood events, which are not common, can happen and may get the people to be caught flat-footed, not be able to anticipate, because climate change has been changing things. What they are used to or what they know in terms of experience can become a surprise in the future, because climate change has made these events bigger and therefore can make them not prepared to handle such an event. So my advice is that we prepare for climate change impacts, those that are bigger than what you have experienced. And if you feel that most of the disasters are happening only in the urban areas and the large hazard events cannot happen in urban areas, I would like to caution you on that it can happen in the urban areas. We thought that as well, that the big floods events can't happen in Metro Manila. Ondoy caught us flat-footed. The rains were more, or the floods were bigger than what we know, than what we are used to. And with climate change, this can happen in Fiji, even in even in urban areas. So my best advice would be to anticipate, prepare for the bigger events than what you have experienced. It can happen anywhere in Fiji because there are a lot of storms that pass by that area in the East Pacific. Prepare for the bigger events. That's my best advice that I can give. And bear in mind that climate change is, I think, real because of the frequency of events. The big typhoons are making landfall in our area. It has happened, and it has caught people unprepared because they failed to anticipate the bigger event than what they know in their historical record.
That's right, Dr. Lagmay. I'm actually what comes to mind is over a decade ago when Haiyan hit the Philippines. You know, the people in Tacloban, they weren't expecting impacts like that, but it happened, and we had to pay the consequences. It's definitely a reminder to everybody that you know, we will experience bigger events even in our cities, and we do need to be prepared for them. We have another question, sir. This one coming from Gerald. This is actually might be connected to the question you answered before the last one. So he asks, given the government's awareness of rising sea levels in Metro Manila, why does it continue to pursue expansion projects such as the land reclamation initiatives in Manila Bay? Maybe you could give some insight on that, sir, if you're able to.
Why does it continue? Well, they're trying to expand the land because land is very valuable. Realty, real property is very valuable. And, the considerations, the decisions, sometimes is not just based on the science, it's also based on business models. So we have to create a balance between what we want developed, how development would ensue in the future, and that has to be consulted with the stakeholders. So the stakeholders would define, the people in the community would define what their vision is for their community in the future, and let them decide what kind of development they wish to undertake.
Thank you so much for that, Dr. Lagmay. We have one last question that we wanted to ask. This is a follow-up from Mr. Marvin Tejeda. He asks, do you think that the effects of climate change cannot be reversed in the coming years until decarbonization happens to plateau the effects? Can we just increase our focus on adaptation strategies? the adaptation strategies of our communities and adjust our efforts towards that aim? So it's a
Yeah,
question of adaptation.
yeah, it's a question about adaptation. With the assumption that there's nothing we can do to mitigate the the mitigate global warming. So what's happening is that since the questions appears to be resigned about climate change mitigation, that there will be continuous greenhouse gas emissions into the future, going into a worst case scenario for climate change, that we resort to doing adaptation. Adaptation means that we are trying to plan communities and trying to anticipate the adverse impacts of climate change through planning. And come the time that they happen, we are prepared and we can address all of those concerns. Now, there's such a thing also as climate adaptation and doing mitigation measures as well in the plans. So if we combine them, we can also make the communities adapt to climate change through preparedness, through planning, and through certain activities that the community can do to address the impacts, adverse impacts of climate change. And at the same time, be able to reduce the emissions of greenhouse gases. Through the planning process, they can introduce certain activities, certain efforts that would reduce global warming through the reduction of carbon and other greenhouse gases.
Thank you so much, sir. We have one last question, and I promise this is the last one before we wrap up our question and answer portion. Tianyuan Ma asks, thank you for the impressive presentation. I have several questions. Given the Philippines' vulnerability to natural disasters highlighted, how specifically can regional climate models improve disaster preparedness? Will the high resolution reanalysis dataset help the adaptation and mitigation in the Philippines? If it helps, under which resolution is it enough for it to be usable? Thank you.
Yeah, that's a very, very important question. When we make plans for communities to make them more adaptive to the projected impacts of climate change, we have to make those plans based on scientific models. It must be science-based and risk-informed. And of course, these climate models for the region are very important, and they need to be downscaled as well to community level. So downscaling is very important. The science is very important. But in these climate models, wherein we see the amount of rain having increased for a certain area in the future, rain per se does not kill. It's not really the hazard. Excessive amount of rain, when it accumulates and becomes a big flood, that's the hazard that kills. So all of these climate models need to be downscaled and processed and try to be translated in terms of the hazard, which is in this particular case, the flood hazard. And they must reflect scenarios of precipitation of the future, because it will translate to flood scenarios that are multi-scenarios, including scenarios of climate change, that can be used for the planning process on how to distribute development in a particular area and try to avoid infrastructure in critical places that are hazardous. Move them away from the hazard, move them away from the flood, so that when the hazard strikes in the future, the big floods happen in the future, the critical infrastructure and development are out of harm's way. And if the infrastructure as well as development and populations are out of harm's way, we do not have any disaster to discuss or to talk about. And when there's development and there's economic progress happening for that community unhampered by disasters, the growth and development will benefit the community, and it will give them a better chance to attain the sustainable development goals.
Thank you so much for that answer, Dr. Lagmay. Can we all give a round of applause for Dr. Lagmay? I think we can do that by emoting here on Zoom with our reactions. Um, so again, thank you for that enlightening presentation and definitely for answering our questions this morning. You've given us a sobering yet insightful look into how the Philippines, particularly um, the greater Metro Manila area, is facing the harsh realities of climate change, from more recent and severe flooding to rising sea levels, ground subsidence, landslides, and increasing temperatures. These are very clear and pressing risks. Um, you also highlighted how rapid urbanization has intensified heat in the region. With nights that are warmer, now more common than ever, and it's a really compelling reminder that understanding these localized impacts is crucial if we're to craft effective science-based strategies for climate adaptation and resilience. Definitely a lot of insights that can also be taken from the Philippines and can be applied to the concept to the context of our regional partners and our neighbors. Now that we've wrapped up our Q&A portion, it's time for us to take our group photo. So may I invite everyone to please turn on your cameras, smile, and join us for this virtual photo opportunity. April will be helping us facilitate this photo op. So over to you, April.
Hi, we have 8 panels to take screenshots of. So I ask everyone to please hold their smiles. Okay, panel 1. Panel 2. Panel 3. Panel 4. Panel 5. Panel 6. And panel 7. Give me a second. So there, we're done. Thank you.
Okay, thank you so much, April, for that. Um, at this point in time, we now move on to the end of our webinar. So we'd like to once again thank Dr. Mohar Lagmay for sharing his time and knowledge with us this afternoon. And once again, this webinar has been brought to you by the UN International Organization for Migration and is co-organized with the UP Resilience Institute. So before we officially close this afternoon's webinar, please be reminded that participants will be issued a certificate of attendance once they have answered the evaluation form. You may find the link to the form in the chat box of this webinar, and a QR code is also flashed on screen to make it easier for you to access. We also would like to take this opportunity to invite you to a webinar co-organized by IOM and the Pacific Islands Forum Secretariat entitled From Data to Action, Harnessing Data for Implementing the Pacific Regional Framework on Climate Mobility. This webinar is planned for the 14th of April 2025, 5 p.m. local time in Fiji. The webinar is supported by the PCC MHS program, and it is hosted on the Technical Working Group on Human Mobility under the Pacific Resilience Platform. Thank you once again, and see you all at our next webinar. Once again, my name is Marcus Rosales, and it has been a pleasure being your host for this session.
We will keep.
Thank you.
Thank you, Sir Mahar. We're going to keep the meeting room open to give everyone a chance to fill out the evaluation form.